So we're showing today how we can actually put sets in Venn diagrams. You know, Venn diagrams are the two circle things. You put the ones that are in both in the middle, etc., etc. So here it says A are the natural numbers less than 20 divisible by 3, and B are the natural numbers less than 20 divisible by 5. So here it says use the appropriate notation, list the set of whole numbers less than 20 that are whole numbers. Typo. Natural numbers. Sorry. Less than 20 that are divisible by 3. So which ones are divisible by 3? Divisible by 3 means I can divide it by 3 and I don't get a decimal, correct? So our first one would be 3, then 6, 9, 12, 15, 18. Divisible by 5 would be 5, 10, 15. Divisible by 3 and 5. So this would be an A and B situation. A intersection B. Which numbers are divisible by 3 and 5? Yeah, 15. And then divisible by 3 or 5, A or B. What are we going to get? 4?
3, 5, 6,
3, 5, 6.
9, 10, 12, 15, 18.
Yes. So anything in either one we're listing, right? So then you have Venn diagrams on the next page. We're going to flip back and forth between them. So at the top, I'm just going to write these down so that actually you don't have to flip back and forth. So on the very top, write down your A, your B, your A and B. So here I'm going to write my A is 3, 6, 9, 12, 15, 18. My B is 5, 10, 15. My A and B is just 15. Now, when we have this little n in front, this means the number of elements in, correct? So we're not actually stating all the elements, we're just saying how many there are. Okay? So how many are in A and B? 1. What part of the Venn diagram is the and part? The middle, the eyeball. So actually, I always say this, the eyeball shape is and. And you might be like, I don't need that. This is a 2 circle Venn diagram. I'm a genius. I don't need that. We're going to go to 3 circle Venn diagrams, and you are going to need it. So, and is the eyeball. Okay? How many are in A and B? There's 1, right? So I go to A and B, and I can put a 1. You always have to start with the overlap first, just so you know. You always have to start with the overlap first, because it's going to include what's already in A and B. So we're going to move to the next one. The number of elements in A. So this should be an A and this should be a B. This should be an A, this should be a B. So I'm going to leave my 1 here that I already found. Putting that there, right? Now they want the number of elements in A. How many are in A? There are 6. In the A circle, how many do I already have in here? 1. So how many are in A only? 5. So we have to do the subtracting, because in that a circle, I should have 6. We agree? I already am counting the 15, the number 15. Yes? So there are 5 that are in A only. Okay? So we're going to go here and we're going to go A and B. 5 and 1. How many are in A or B? 8. Or is the snowman? It's hard to draw sideways. It's a 2-circle snowman. Don't judge him. He's equally as good as a 3-circle snowman. The snowman is the or. The whole snowman, including his stomach. People will think this is and this is and that isn't. It would be a collapsed, it wouldn't be a snowman if he didn't have a stomach, right? So all 3 pieces are the or. Now we said in the or we have 8. We agree? Can we find out how many are in this missing piece now? How many would be here? 2. Because in this whole snowman, I should have 8. I already had it filled in with 5, 1, and 2, right? So we have 5, 1, and 2 sitting here. How many elements are in B? 3. Does that make sense in this case? In the B circle, there's 3. Is it true? Yeah, because I would count both of them, right? The whole B circle has 3. That's true. Okay, what the heck is this? So we'll fill in what we have. 5, 1, 2. Is this symbol an and or an or? It's an and. Does this one have a little n out front? No. We're going to put it there for ease, actually. If we don't put the n in front, we have to list the elements that are there, so we'll do both. We'll do it with the n and we'll do it without the n. Okay, but we'll do it with the n first. So that symbol you're telling me is and. Okay? So we want what's in A and not in B. What's in A and not in B. Instead of saying and not, you could say but not B as well. So how many are in A but not in B? How many of these in A are in A but not in B? There's 5. There are 5 of them in A but not in B. I'd have to cover up my B, correct? So there's only 5 of them that are in A but not in B. This is also like saying A only. If I wanted A and not B, like this, I would actually have to list those elements, right? There's no N on this, is there? So if it's written like that, I actually have to list the elements. So what are the elements that are in A but not in B? 3, 6, 9, 12, 18. Right? They're the ones in A only. And how many of them are there? 5. So it does show that it actually works, right? Those are the ones in A only. Now I've filled in the circles. Have I filled in the entire Venn diagram? There's actually numbers that are not in A or in B, aren't there? In the universal set. So if I go back a page, I'll show you. So if you look here, in my in the universal set, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Correct? In A or B, I have 3, 5, 6, 9, 10, 12, 15, and 18, which is how many? 1, 2, 3, 4, 5, 6, 7, 8. Correct? I have 8 of them. How many are in the universal set? There's 19, correct? In the universal set? There are 8 in OR. So there are 8 in the snowman. We agree to that. So how many are outside? How many numbers are outside? 11. So if we go back to saying n of A, this is not A. So how many are not in A? So how do I do that? I cover up A, which is the 5 and the 1, and how many are not in A? 13. The 11 and the 2, right? How many are not in A? 11 and 2, 13. So here I have 5, 1, 2, 11, A, B. So we'll put an N in front of this. Oops, an N in front of this for ease. Now, not A and not B seems awfully confusing, right? The great thing that you can learn and that they tell us we have to teach you is that if they're both negated, you can write them a different way. So I have not A and not B. You see that, right? What I can do is I can rewrite this as the number of elements in. I can go A, B, put the not out here instead. And then what happens is your middle symbol flips. So my middle symbol currently is an intersection. It's going to become a union. If it's a union, it becomes an intersection. Okay? So you can write the not outside, and this and union or intersection is going to turn to an or, a union. Which honestly, this is a lot easier to find because this is saying not in A or B. A or B is what shape? What is the or shape? The snowman. The snowman is the or shape, correct? So I'm saying, how many are not in the snowman? That's literally what I'm saying. So how many are not in the snowman? 11. It's a lot easier than trying to be like, okay, not A, and not B. So I'm thinking all the ones not in A, all the ones not in B. Then I can list them. That is, I guess, a lot harder than if you're like, put the negation out, and you say, okay, A or B is the snowman shape. I want what's not in the snowman. Oh, there's 11 of them. Done. Okay. One, 2, and 11. Now, or is tricky because or, if it's in either or, I list it, correct? So for these ones, I'll just start like circling the areas that exist for both of them. So here I say, okay, I want not A or B. So if it's in not A or it's in B, I list it, correct? Because or means in either or. So what is not in A? Which of these areas is not in A? The 11 and the 2. Cool, I've covered that one. And then I have to also list all the, because or B. What number am I missing? The 1. 5 is the only one that's not in this set. Because I have to list what's not in A, so 11 and 2, or in B. B has 1. So how many is that? 14. And I'm going to go over a page. Okay, I want you to shade these regions. The intersection of A and B, the union of A or B, the complement of A. So try and just shade them. Use pencil. The intersection of A and B is like A and B. And is what shape? The eyeball. So it's the overlap. So it's where the two overlap. Then we have A or B. And or is what shape? The snowman. Okay. Now the next one wants the complement of A. So not A. So basically we're going to shade everything but A. And it didn't go outside the box. It's tiny. So the last Venn diagram I did, I wrote how many elements there were, right? And you just wrote the number like 3, 1, 11. Like we just wrote the number, correct? The other type of Venn diagram you can be given is ones with dots. Do you see how there's more than one thing written in each section? When I did the sections, it was like 3, 1, 11. That was how many were there. The other way that they can describe a Venn diagram is they can literally list what elements are in it. So like physically see the elements in front of your face, right? How do you know that they're elements instead of sums? There's more than one per section, but also they put the dot behind it. So this is the number 2, this is number 9, 8, 1, 10, 7, 29, 16. So it tells you, that's how it shows you that it's the actual element, okay? Rather than the sum of elements. So I want you to try this out. I want you to list from here, you're going to list the elements. So I'll do P first. So we have to list the elements from the Venn diagram for P. What numbers would I put if it's for P? 298, but also 1 and 10 because it's still in P. Happens to also be in Q, but I do not care. It's all the elements in P. So it'd be 1, oh, the board. It's testing my patience. 8, 9, 10. That line isn't supposed to be there. Please don't write the line in your notes. Okay? You guys try these out. Up to F, I'll help you with G and I. These we're going to do together. I want you to do up to F. Try it out. The elements in Q are 1, 7, 10, and 29. P and Q is the eyeball, so it's 1 and 10. P or Q is the snowman, so it's actually everything but the 11 and the 16, right? Whole snowman. So 1, 2, 7, 8, 9, 10, 29. Make sure you have the squiggly brackets because that says the set of, and then you put the elements in it, right? Now what's not in P? So everything that's not in P is, I guess I could do it right here. Not in P is 7, 11, 16, and 29. Because you'd literally cover up the P and list everything else, right? The next one's not in Q. We cover up the Q with our hand, and we get 2, 8, 9, 11, and 16. And that can be written like this. This can be written like this. This is like P and Q. This is P or Q. Right? They can be written in set notation as well. So this one here is not P and not Q. In words, it's not as easy to understand. Not P is like this, and not Q is like this. What did I tell you to do immediately if they're both negated? Not do it that way, right? Rewrite it. We agree? So how do we rewrite it? We put the P and the Q inside the brackets, the not outside the brackets, and the intersection becomes a union. We agree? So now I'm asking you for all the elements that aren't in the what? P or Q. And P or Q is what shape? The snowman. So I want what's not in the snowman. So 11 and 16. Look at this one. I, it's not P or Q. This is this. It's actually the exact same, isn't it? So this one is 11 and 16. Then that one is not P or not Q. So that's the same as saying not P, union, not Q. When they're both negated, I rewrite it. P, Q, not outside, and the union becomes an intersection. So I want what's not in P and Q. So I want what's not in the eyeball. So I list everything but what's in the eyeball. Correct? So P and Q contains 1 and 10. I list everything else. So it's going to be 2, 7, 8, 9, 11, 16, 29. Just so you know, they don't have to be listed in order. I just like listing them in order. But if you, as long as you have all the same numbers as me, it doesn't matter what order they're in. Then the one below it is not P and Q. So it's P and Q not. So it's the exact same, right? These are the exact same. 3, 2, 7, 8, 9, 11, 16, 29. Which two pairs of sets are identical? G and I and H and J. So this one doesn't list elements, right? This one lists total numbers because there's no dot behind it, right? There's a 12, there's a 3, there's a 7. We agree? Try this one out. See if you can answer it. As the diagram displays the number of students who are members of student council and the number who are members of the yearbook committee. How many students are on student council? Does it say student council only? No, it says student council. So if it falls in the student council circle, I count it, correct? So what am I going to add together? The 12 and the 3. So your answer is 15. Exactly. Now they want on both student council and the yearbook committee. How many are there? 3. It's the overlap, right? And this one says on the yearbook committee, but not on student council. So that's basically yearbook only. That's what they're telling you. How many are there? 7. On student council or yearbook. Or gives it away. What does or mean? The snowman. So I count all the pieces of the snowman. Snowman always has 3 parts. Okay? So 12, 3, and 7, which is 22. Exactly. Flip over. So this one here says, in a homeroom of 20 students. I always break everything down to help myself out. So 20 students is the total. So I know my Venn diagram, better add to that. 15 take math. 12 take social. 10 math and social. Show this information in a Venn diagram. Okay. Venn diagrams always have a box around it because you need to have that box because what's not contained in the circles would just be floating around the world, right? They need to be in a box and that box should add to 20, right? That's the key thing. Now, if you want to use short form variables like an M and an S, you have to say off to the side, let M represent math and let S represent social. If not, you have to write the whole word. Math above the one, social above the other. Okay? If you don't. So, because I wrote the let statements, I can go M and S, but if not, I would have to write math and social, the whole word. Okay? Where do I have to start? Math and social. I need to start in that middle piece every single time. You're always starting from small shapes to bigger shapes. Now, why do I have to start in the middle? Safe catch. You have to start in the middle because why? Yeah. You're minusing it. Yeah. Because if I don't start in the middle, 15 take math. If I put a 15 here, I'm wrong, correct? Because the math and social people are still taking math. They just have to be taking social. They're no lesser of math people. They just have to be taking social as well. So I have to start at the and first. So I put a 10 here. If I don't know the and part, guys, I have to find it. Okay? So math. Math should have how many in it now? Math only. Yeah, 5 here because we need to have 15 total. You're right. So because we have to have 15 total, we subtracted off and we put a 5 there. Do you see? If I tried to do the 15 first, I don't know. What would I do? Put a 15 there and then start subtracting? Doesn't make sense. And then social, 12 takes social. If it said 12 takes social only, guys, I would put a 12 here. If it said social only, or social but not math, 12 will go there. But it doesn't. It says social. So this whole circle needs to have 12. So how many take social only? 2. And now we can't forget the outside. Everyone forgets the outside. Remember, there are 20 students total, correct? In the or, math or social, it contains how many now?
3.
Math or social? 17. So how many are outside? 3. And now the question says, how many students take math, neither math nor social? 3. We don't write just 3 though. It's a word problem. It's a written response. We have to have sentences. And you might be like, I don't need sentences. So then you don't need a full mark on your diploma. Like, because that's what it's going to have. It's up to you. You make the option. It's your mark. You choose how you want. But if you want full marks, you need a sentence. I'm not just saying that. It's legit. Okay? So 3 students, and you're literally just reciting the question that they gave you. So it's a sentence I can get on board with, even though I'm not a huge fan of writing. So 3 students take neither math nor social. I wish I was good at writing. Life would be so much easier. Okay, that's it for today. You don't have any homework. You do have to submit that homework into Google Classroom though, the stuff you have to write today. But you have a nice weekend with no homework.